Today we're going to fix some issues with aiming, looking, and shooting for both the player character and AI-controlled characters. We'll introduce a more sophisticated way for NPCs to identify other characters as hostiles or friendlies by using a faction system, and we'll add some nice armbands to the characters with the colors of their faction. We'll also improve the graphics. This is not exactly the focus of this course, but I said why not? We'll see how some minor tweaks to the lighting and post-processing can really make the game pop. It's important to introduce some visual progress as you make your game to keep you always motivated, so we're going to do just that. Let's fix some issues with our gameplay systems. We're going to focus on shooting, aiming, and looking because these are a little bit problematic. So for example, when I'm holding the gun like this, if I click on the attack button, which is the left mouse button, I'm able to shoot. And we don't want that. We only want to shoot when you're aiming the gun. This applies for the player's character as well as other NPCs. And here I have the NPC from the last video. He is currently looking at me, or trying to. So the looking code is not working properly. The turn-in parameter in the animator is not set properly. Here I've removed the gun from the NPC, but the handbrakes are still working. So we need to fix all of these issues. Let's go to the NPC script. Here I created a gun properties and delegates region where I have the gun reference, the carrying gun boolean, and the try shoot unity action. Here I used to have the public unity action set aim, but we're not going to use it anymore. We're going to manage aiming in here. So we're going to define a private aiming boolean set to false by default. Then instead of the unity action, we're going to actually just use a regular method, public void set aim. If carrying gun is true, we're going to set aiming to the aim value. Otherwise, we'll set aiming to false. Then for the aiming property, we're simply going to return the value of the aiming variable. Now, because our NPC animator used to subscribe to the set aim action, we're going to modify the NPC animator. So here in my NPC animator, I removed the subscription to the set aim action. And in the update method, what we're going to do is if NPC is carrying a gun, we're going to set the layer weight of the second layer to 1. This is the carrying gun layer. And we're going to set the gun object to active. Otherwise, we're going to set the layer weight of the carrying gun layer to 0. And we're going to deactivate the gun object. Then we're going to simply set the aiming boolean to npc.aiming in the animator. So this makes our NPC animator much simpler. In the NPC look script, one of the main reasons why aiming was not working is simply this. Here in a previous video, we've defined update animator turn parameter, and we're supposed to give it the target position. And instead of the target position, I was giving it the direction to the target. So we're going to modify this. We're going to give it this position right here. And this should fix the problem. However, we still have one small detail. In the onLookAt method, we're only going to activate the right arm rig and set the position of the spine aim target to the aim target local position rotated by 45 degrees. Like we discussed in a previous video, we're only going to do this when we're aiming. Otherwise, we'll simply set the spine aim target to the aim target. Then down here in the late update method, we make sure to set the left arm rig's weight to 0. This should allow us to animate the characters properly, whether they're carrying a gun or not, and whether they're aiming or not. Right arm and left arm rigs are designed for carrying a gun and aiming it. When the character doesn't have a gun, it would look silly if they held their arms up like they're carrying an invisible weapon. That would be funny, but it's not the point. Back to the editor, I'm going to right-click on the NPC properties in order to keep this inspector open. Okay, so the character is looking at me. They seem to be turning all right. The turn parameter is perhaps too small, but at least it's working. So if I run, notice how they will set the turning parameter properly and they'll play the turning animations. So let's remove the gun. Okay, so the character is also able to animate itself. properly. Now let's go back to our behavior tree and let's actually enable aiming. So let's go to behavior trees, scripts, and test interruption. So we'll uncomment the line where we set aiming. Now they're aiming at me. So that's exactly what we want. Let's remove their gun. Looking at the handbrakes for the NPC, I see that they are enabled and they should not be. So in the NPC look script, we're only checking if NPC is aiming and we're enabling the right arm and left arm rigs. However, in the NPC script, we're only going to change the aiming variable if carrying gun is set to true. But this is exactly the issue because when are we calling set aim? We're doing it in the set aim action. So we're not doing it every time. We're doing it once at the start of the combat sequence. So we need to fix this. Let's go back to NPC look. And here we're going to also check if we're carrying a gun, if NPC carrying gun. So we're disabling carrying gun, but in the NPC look script, if you notice here, so in the update method, we're only going to disable this when the timer has reached 0, but as long as the NPC is looking at the player, the timer will never reach 0. So just to make sure, I right-clicked on the weight of the right arm rig and I clicked on find all references. So these are all the references where we change the weight of a rig. So the right arm rig is indeed only changed in the onLookAt method. So the spine rig is fine. It will be enabled whether we're carrying a gun or not. However, for the arm rigs, we need to disable them whether the look timer has reached 0 or if the NPC is not carrying a gun. So what we can do is set the weight of the arm rigs in the onLookAt method. If we're not aiming nor carrying a gun, we should set the weight of the arm rigs to 0. Okay, let's disable the carrying gun. Okay, so it works for the arm rigs. However, the spine rig is still looking 45 degrees to the right as if we're aiming. Maybe we should expose the aiming variable in the NPC. Let's go to the NPC script and let's expose this in the inspector. Let's go back to the NPC look script. So we're setting the spine aim target to aim target. I feel that this is wrong. Yeah, so the spine aim target is set at aim target. This is wrong. We should not be doing that. So what I'm going to do is actually set the position rather than set the whole game object or the transform in this case. So let's set it to aim target.position. Yeah, we should keep the reference to the spine aim target intact. We should not be changing it. Okay, let's do it one more time. I'm going to remove the gun and now it's working properly. So one last detail is if you notice how slowly the NPCs look. For the player's character, I set the turn speed to a high value in order to not lag behind. So if I go to the player NPC, in the NPC look, if I set the turn speed to like 30 here, if I'm aiming, you'll notice how the character takes a while to turn, as you can see. So it's a little glitchy. So we're going to set this value on the NPC prefab. So apply to prefab NPC. That way, all NPCs will have this value by default. Perhaps a value of 360 is too much for the NPCs, especially when you're making a stealth game. So the character is supposed to slowly turn to random angles, but they're turning almost instantly. So we have the aim target here, and we have the spine target. So actually we need to limit the angle that the aim target can be at. Okay, so first let's draw some gizmos to display the aim target. Let's go to Unity methods. So we're going to draw a line from the NPC sensor position to the aim target position. Then we're going to draw a wire sphere at the aim target. And actually we're only going to need to limit the angle of the aim target because the target of the spine is computed from the aim target. So if we look in the onLookAt method, when we set the aim target position, the position of the spine aim target is going to be set depending on the aim target. Since NPC will only be available at runtime, so we'll have an error here. So let's make sure that the NPC is set. Let's go back to the onLookAt method. After setting the position of the aim target, we're going to call a clamp aim target angle method. This method will make sure that the aim target does not exceed a max angle between the direction to that aim target and the forward vector of the NPC. So let's define it down here. First, we set the maximum angle. Let's set it to a value of 30 degrees. Then we define the forward vector, which is the NPC's transform forward vector, and the direction to that aim target, which is aim target.position minus npc.sensor.position. And we make sure to normalize the vector. Then we get the angle between forward and direction using vector3.angle. If this angle is greater than aim target max angle, we're going to use vector3.rotate towards from forward to direction, and we're going to set the max radiant delta to aim target max angle. And because this angle is in degrees, we need to convert it to radians using mathf deg2rad. And then we're going to set the max magnitude delta to 0. Then finally, we set the position of the aim target to npc.sensor.position plus clamped direction multiplied by vector3 distance between npc sensor position and aim target position. So we conserve the distance of the aim target and we just modify its angle. So this should do it. However, if we want to test this properly, we have to define a script because it will get complicated if we keep using our test interruption behavior tree. So in the behavior trees, even though this is not a behavior tree, we'll create a test aim here, test aim. So we're going to inherit from NPC component, and we're going to need a reference to a transform. In the update method, we'll call npc.setAim, or I should say npc.lookAt, and we'll give it target.position. Let's also define a boolean for aiming. Let's set it to false. We want to only do this once, so, or better yet, we'll do it in a method, and we'll have it in the context menu. So in this method, we're going to set npc.setAim to the opposite of npc aiming. Okay. Now in our scene, let's go somewhere else. Let's instantiate an npc prefab. So let's go to content, prefabs, npc base, and then instantiate our npc over here. Let's add the npc or the test aim script here. Let's create a target. So let's create an empty. Let's call it aim target, and let's move it outside of the NPC. So we're going to have it somewhere over here, because we're going to be moving this, but we still want to see the aiming gizmos. So let's go back to our npc look script. Let's just add a draw gizmos boolean over here. Let's do it here at the top. Serialize field. Let's add a header gizmos, a boolean draw gizmos. Let's set it to false by default. And then let's also have the gizmos colors. Let's set it to cyan by default. Actually, let's move this down at the bottom of the inspector. I think that's going to look better. So in the onDrawGizmos selected method, we're going to change it to onDrawGizmos, and then we're going to, so if npc is null or drawGizmos is false, we're going to return. And then here we're going to use our gizmos color. So that way, even if the character is not selected, we can still see the gizmos. Okay, so now the goal is that the aim target over here, we're going to move it very quickly, and the NPC is going to try to look at it. Okay, so let's go to our NPC. Here for the test aim script, we're going to assign aim target here. And in the NPC look script, we're going to enable draw gizmos. So I don't see a reason why we should expose the maximum angle here. I guess an angle of 30 degrees is reasonable enough. We don't need to change it. We're going to ignore the game window here. We're going to just focus on this. Okay, so in our NPC, let's grab the inspector. Let's go to the NPC test aim. Let's toggle aim in, toggle aim. So the NPC is looking at the gizmo over here. Okay, that's good. So let's move the aim target. So the NPC is following. Now let's move it very quickly. Our NPCs are able to look at targets in a realistic way. And that's important because you don't want your NPCs, especially like I said before, if you're making a stealth game or even something like Dark Souls as a player, you want to get behind NPCs and stab them in the back. So if NPCs turn very quickly, that can be frustrating. Now we can remove the NPC and the aim target. We don't need them anymore. Now we have another problem. The NPC looks fine as long as it's calling the look at action. But if you noticed, when it stopped calling the look at action, the arm rigs have been disabled. So the question is, should we change the weight of the right arm rig and the left arm rig in the update method instead of the onLookAt callback? So let's try it. So we're going to do this in a method, update arm rigs, and we're going to do this. Let's comment these out. And we're going to remove the code with the spine aim target. So even if we comment this out, we can still call our method over here and it will be pretty much the same result. So let's comment this out and instead let's do it in the update method or in the late update method. Let's update our arm rigs over here. And in here, we don't need to change the weight of the arm rigs. So let's comment this out because basically the arm rigs are always going to be active when we're aiming and carrying a gun. There's no reason that they will stop being active when the NPC is no longer calling the look at action. So on the player's character, the code works, as you can see. And let's test it on the NPC. So I'm going to hide. Now the problem is the spine because its weight is set either to 0 or 1. If you've been following along since the beginning, we faced this problem many times and the solution to that is to use the lerp or mathf lerp to smoothly transition between two values. So we're going to do this now. Let's create a region here. Let's call it rig manipulation methods and we'll have our method in here. We'll also define a set spine rig weight method. This will set the weight of the spine rig. So let's use these methods whenever we want to set the weight of the spine rig. So in the onLookAt method, we're going to call our method with a weight of 1. And in the late update method, we're going to call it with a weight of 0. So we don't need this code over here. And in this method, we're actually going to use a mathf lerp. So instead of setting the weight directly, so let's define a smoothing factor here. Let's set it to a value like 7 or 5. If you want, you can expose this in the inspector like we did before in many videos, but we're going to have it as a local variable for now. So we're going to use mathf lerp between spine rig weight and the target value, which is the weight, with a t parameter equal to smoothing times time.delta time. We're testing on the player. Let's make sure that the player has a turn speed of 360. Okay, now let's test our NPC here. Now the spine isn't disabled instantaneously. There is some smoothing going around. So the problem that remains is actually in here, when setting the position of the spine aim target, we're jumping from these two values almost instantaneously. Let's also use a lerp over here. And actually let's do it in a method as well. So let's define a set spine aim target position. It will set the spine aim target position using lerp from the current position to the target position using a t value of 5 multiplied by time the delta time. And let's use this method in the onLookAt callback with this parameter. And let's use it down here as well. So as you can see, the animation of the NPC is much smoother. Of course, this is not exactly an ideal solution. So an ideal solution would be to find animations that do not require us to offset the spine aim target by 45 degrees. But still, this is better than what we had before. Okay, now let's fix the fact that we can only shoot when aiming. Let's go to our gun script in NPC combat gun. First, we're going to disable this line. I was using this as a fix when we didn't have the arm rigs, but now that we do, we're going to disable this. And in fact, we don't even need to subscribe to the lookat action. So we're going to simply remove this and remove the subscription to the lookat action. Here in the try shoot method, we're going to check if NPC is aiming. And let's also check if NPC is carrying a gun. So if NPC carrying gun is false, this is not really going to do anything because if we're not carrying a gun, the gun itself will be disabled. But anyway, let's do it. We use an OR. If carrying a gun or aiming is false, we're going to return. So ideally, you would have this code in a weapon controller script, for example, not directly on the gun because this gun is attached to the actual gun and we could have multiple guns on the character. Okay, now with my player character, I'm going to press the left mouse button. All right, nothing happens. And when I aim, I'm able to shoot. Okay, so with this, we have fixed our looking, aiming, and shooting code. In our NPC script, we have a team property. This allows an NPC to determine if another NPC is hostile or not. This is a basic way to handle hostility. We want something slightly more sophisticated. And I also want to add something visual to the characters in order to identify their team, like an armband or something. And it would be nice to have a button on the UI to toggle the team of the player. So if you wanted to do some quick tests, we could do it through the in-game UI. Okay, let's go into our NPC script. This is our team enum. We have blue team and red team. And this is our team property. A while ago, I moved the isHostile method from the NPC sensor to the NPC script, but it very much does the same thing. We consider another NPC as hostile if our own team is different from the other NPC's team. Now let's go to our NPC folder and let's create a new class. Let's call it faction. I could have called it team, but I believe faction is a more expressive name. This is going to be a scriptable object. Let's add a create asset menu attribute. Let's add a list of hostile factions. And let's add a isHostile method that will return a boolean. So it will check if the faction that we give it as parameter is contained within the hostile factions list. Let's also define a color property. Back to our NPC script, we're going to replace the team property with a faction. We no longer need the eTeam enum. And down here for the isHostile method, to check if another NPC is hostile, we're going to check if the faction of our NPC is hostile to the faction of the other NPC. If the faction of our NPC is null or the faction of the other NPC is null, we'll consider that they're not hostiles. In NPC sensor, in the isHostile method, we simply return npc.isHostile. Now let's create an NPC component that will enable or disable parts of the character depending on the faction, and we'll want to use this to add armbands to our characters in order to identify their faction. So for a lack of a better name, I thought of NPC faction uniform. This will inherit from NPC component. Let's define an inner class called uniform, which will have a reference to a faction, and the list of game objects for the uniform parts. Let's make this serializable to display it on the inspector. Let's add a setActive method that will loop through the uniform parts and call setActive on them. Now back to the NPC faction uniform class. Let's define a list of uniforms. In the start method, we're going to deactivate all uniforms. Then in the update method, if the faction of our NPC is null, we're going to return. Then we're going to loop through the list of uniforms and we're going to call setActive on each uniform. If uniform.faction is equal to our NPC's faction, then that uniform will be active, otherwise it will be inactive. We're doing this every frame just in case an NPC changes factions. We don't have to do this every frame. We can, for example, have an action that will be triggered when the faction changes, and then we're going to change the uniform. However, since this is a script that we'll use for prototyping, it doesn't matter that much. Back to the editor, let's go into the NPC prefab. Let's go into root, hips, spine 1, spine 2, then right shoulder, then right upper arm. And we're going to add an armband here. So we're going to right click, 3D object, cylinder, and we're going to remove the capsule collider. And we're going to transform it to fit the upper arm of the character. Okay, let's rename the object. Let's call it armband. And on the NPC, let's add NPC uniform, faction uniform, and let's right click properties. So we keep this inspector open. Then we're going to go into our content folder, materials. Let's create a new material called mUniform. Actually, let's create a folder called uniforms, and let's have our material here. We'll actually create multiple materials. We'll have one material per faction. Maybe let's define our factions first. So let's go into our data folder. Let's create our factions here. Let's create a factions folder. Then here we're going to create a faction. Let's go to create game faction. Let's just use a red faction and a blue faction. Let's duplicate this and rename it to red faction. In the blue faction, we're going to add the red faction to the hostile factions list. We ended up not using the color property. Perhaps we're going to use it in the UI. So let's set it here. Let's choose a blue color. And for the red faction, let's add the blue faction to the list of hostile factions. And let's change the color to red. So my initial idea is that we would modify the materials on the uniform parts and we're going to assign them the color of the faction. But this approach that we've implemented gives us more freedom. So back to our character. Here, let's change the name of the armband to armband red. Then let's have another one, armband blue. Let's go back to our materials. Let's rename the materials to mUniform blue and mUniform red. Then let's change the colors. So I'm going to assign the materials to each armband. Now let's disable the red armband. We want to modify the blue material. Let's choose a blue color here. Let's add some emission. Let's increase the intensity so it would be very visible. Let's actually make the armband smaller. This is a little bit too big. Now let's copy the properties of this material and let's disable the blue armband and enable the red one. We're going to paste the properties and we're going to change the color and also the color of the emission. Maybe that's a bit too much emission. Let's lower the intensity a bit. Yeah, let's make it smaller as well. Let's add the same armband to the left upper arm. Now in our NPC factions uniform, we're going to add two uniforms. The first one is going to be for the blue faction and the second one will be for the red faction. And in the uniform parts, we're going to add the blue armbands here and the red armbands in the red uniform. Okay, that's it. Yeah, I didn't assign the factions. So let's assign the blue faction by default for our NPCs. Blue faction. And in our player, let's go to our player character. Let's give them the red faction. So the player character should have the red armbands and the other character should have the blue armbands. So now we clearly identify which is which. And let's test the hostility code. So if I go in front of the character, the behavior tree should work properly. He's considering me a hostile and he's aiming at me. So this works and the emission gives this a nice lighting effect. It looks like the armbands have LED lights in them, which is pretty cool. Now all we have to do is add a button on the UI to toggle the faction of the player. Let's go to our second scene view. Here I've added a zombies button that will spawn a bunch of zombies, but we'll see this a bit later. Now let's add a button here. I'm just going to grab one of these buttons. Actually, I'm going to grab this whole panel and duplicate it. Let's add a Text Mesh Pro text here. I'm using the Aoboshi1 font. This is the same font that I'm using in the speech bubbles of the characters. Let's make this label a bit bigger. So we're going to display player faction and we're going to have two buttons to switch either to the blue faction or the red faction. I'm going to remove these buttons. I'm just going to keep one. So let's go to our UI manager and let's add a method. Maybe down here in the UI control methods. Let's call it change player faction and give it a faction as parameter. Then we're going to set player.character.faction to the faction. That's it. Now let's go back to our button. So let's rename it to change faction button. And in here, in the onClick callback, we're going to change it to UI manager, change player faction. And we're going to give it the blue faction. Let's change the text to blue faction and we're going to color it blue. Maybe not, yeah. Let's not give it a color. Then we're going to add another button down here. Let's change the text to red faction. And in the onClick callback, let's change the faction to red faction. Now let's test this. We're going to run the game. Let's test our UI. I'm going to press escape, then change to the blue faction, then change to the red faction. So if I change to the blue faction, normally the other character should not trigger, yeah. So the behavior tree does not change to the combat state because I am a friendly. Now I'm going to change to the red faction. And now he's triggering his combat branch. So this works. This makes it very easy to test. So I'm noticing a problem with the aiming. So if we aim up or down, the character is limited to the 30-degree angle that we've defined in the NPC look. So we need to separate that limit. We need to have a different limit for the horizontal and the vertical angle. Let's go to NPC look and we're going to change the clamp aim target angle. We're going to have a different limit for the horizontal angle and for the vertical angle. Let's rename aim target max angle to horizontal angle limit. Let's set it by default 15. Then let's define a vertical angle limit. We obtain the horizontal direction by taking the direction vector and setting its y coordinate to 0. If angle is superior to horizontal angle limit, we'll obtain the clamp direction. In fact, let's rename direction H to horizontal direction. Then we're going to restore the y component of the direction to the clamped direction. Then we're going to set the position like we did previously. And in fact, that would be enough. So we only need really to limit the horizontal angle, no need to limit the vertical angle. So we're going to ignore this. Let's remove this line. Okay, now I'm able to aim up and down just fine. And the NPC characters are also able to aim. Now let's add something that really has nothing to do with this series. So we're going to make our scene beautiful to look at, because from my own experience in game development, if something is beautiful to look at, if it has good feedback, it gives you more motivation to add more stuff to it. So we're going to start with our global volume. Here we're using the sample scene profile, which comes by default with URP. So let's change it. In the tone mapping, let's set it to ACES. So this already gives us a nice look, and we're going to adjust the colors. So let's add a post-processing color adjustment effect. In this effect, we're going to set the post-exposure. We can also shift the hue and the saturation, but this is too much. If you're making something stylized, you might want to change this, but we're not going to do it. We have a vignette effect, which darkens the borders of our screen. This is great because it draws attention to the center of the view. So in video games in general, the most interesting things happen in the center. So if you draw the viewer's attention to the center, your game will pop more, but we're not going to do it this way. We need these effects to be really subtle. If it's too much, then it ruins the experience. We also have some bloom. The bloom adds this nice glowing effect to bright areas. And again, we need it to be really subtle. We don't need it to be in your face, if you know what I mean. Let's also add a cinematic aberration effect. So if you notice in the edges of our screen, we have a distortion effect, which also works like the vignette. It draws attention to the center of the screen where interesting things happen. This effect is used in a lot of modern games like Elden Ring and many other games. So we're going to just add it, but in a subtle way. So a value of 0.2. Yeah, 0.2 is good enough. We can also add a shadows, midtones, and highlights effect. This allows you to change how your shadows, highlights, and midtones, like the name suggests, how these elements will look. So if we enable these checkboxes, we're able to change the brightness of the shadows in here. So if you really want that noir look, you can push this all the way to the left. So this gives it a really gritty look. This could be a style that could be interesting for a horror game or a detective game. See how the post-processing effect changes the feel of the game. Yeah, so you can play with these values until you get something that you like. We're not going to go in that extreme, so let's keep it at a reasonable value. And then for the highlights, let's adjust the post exposure a bit to make the scene a little bit brighter. Now let's add some fog in the distance. Let's make it linear. As for the color, it's always a good idea to sample a color from the skybox. but in our case, we'll use a white color. Let's have the fog start at 50 and end at 200 units. Now let's work on the skybox. So I'm using the skybox provided by the Unity starter assets. Let's clone it. Let's call it Robot City Sky and let's move it to our materials folder. Let's use it in our lighting settings. So let's open the inspector. So in the skybox, we're able to control the size of the sun and the convergence, which is the softness of the disk. So we can make it really soft or sharp. Then we have the atmosphere thickness, which simulates the density of the atmosphere, which affects how the light scatters. So if we have it at 0, it will be like if we're on the moon, 0 or very thin atmosphere. But if the atmosphere was thick, it will be closer to like Venus or Saturn. So let's have it somewhere in the middle. Then we have the sky tint, which is the dominant color of the sky. Let's set it to a blue color. Of course, this is affected by the thickness of the atmosphere. To get an Earth-like atmosphere, we should keep our atmosphere thickness around 1. Then we can choose the color of the sky. And also the color of the ground. Let's keep the exposure at 1. Okay, back to our lighting tab. Let's create some lighting settings for our scene. Let's call them Robot City Lighting Settings. We're going to activate real-time global illumination and we're going to disable baked global illumination. Let's set the light map parameters to high resolution and let's generate the lighting. If we go to our scene's draw modes in real-time global illumination, if we enable any of these, you'll notice that nothing is visible. So our bake light maps was completely useless. Okay, so you have to select all your level geometry. Fortunately, I've organized them all in here. Then go in the inspector and check contribute GI, which is global illumination. And in here, I've set the indirect resolution to 1 and the light map parameters to very low resolution, just so the light maps generate very quickly. So now if we go to the draw settings in the real-time global illumination, you can see that there is some data on the light maps. So once you're satisfied with the low resolution, then you can increase the resolution a little bit. Let's set it to medium and then bake again, generate lighting. Now you will notice that some areas of the map are a little bit darker. So for example, this area here was very bright, which didn't look natural. But if you bake global illumination, these areas will look more natural. So I'm going to cancel and I'm going to increase the direct resolution. Then click on generate lighting. So this may take a while. I'm going to cut the video here. So while we wait for the global illumination to bake, let's go to our post-processing effects. These effects are a little bit much, so I'm going to reduce them a little bit. So let's go to the color adjustment. Let's increase the exposure. In the shadows, midtones, and highlights, these are definitely too much. So I'm going to darken the shadows just a little bit. And for the highlights, then for the chromatic aberration, I think I'm going to reduce it a little bit. Same for the vignette. Let's reduce the intensity a little bit. So we have to decide whether we want to keep the ACES tone mapping or not. So if we switch back to none, this doesn't look as good. So let's keep it and let's change the materials on our armbands. In fact, let's make them a little bit smaller because these are a bit much. So let's reduce the scale and let's go into the materials, uniforms. Let's change the emission to real time. Let's change the material here. This looks like a purple material. So let's change the emission. Okay, so let's change it to this light blue color with an intensity of 2. Then for the red armband, I'm going to disable the armband on the left arm, just so we can see it better. So perhaps we can adjust the position of this blue armband. So let's change the scale a little bit. And then for the material, let's choose an intensity of 2. Or perhaps an intensity of 3. But I don't want it to be too bright. So an intensity of 2 will do. Perhaps let's fix the position a little bit. Let's see how the red one looks. Okay. Let's fix the scale a little bit. Let's check out the blue one on the left arm. Yeah, let's change the position a little bit. Something like this. Okay, so this looks good enough. We're going to stop at this point. So our real-time global illumination has been generated. If we go to the drawing modes and change to albedo or indirect. So here we have an idea of how the lighting will work. These areas are darker and will ultimately look more natural. I must say that the game looks amazing right now. So it's a really big jump in graphics from the previous iterations. Yeah, I like it a lot. And the armbands look really nice. I really love how we made them small, unlike how they were previously. I also like the skybox. Yeah, so you can notice the fog in the distance. So all of this looks good. These kinds of changes make you want to add more things to this. With this, we've reached the end of this video. Thank you for watching. Thank you for tuning in. Remember to subscribe, hit like, post your comments below. And if you have questions, I'll be happy to answer. Stay tuned for more videos and see you in the next one. Bye bye.